So moving forward, let's consider the next one from binomial. For a positive integer n, 1 plus 1 by x whole to the power n is expanded in increasing powers of x. If 3 consecutive coefficients in this expansion are in the ratio 2:5:12, then n is equal to, little lengthy, calculative, but let's try. This says NCR minus 1 is to NCR is to NCR plus 1 is equal to 2:5:12. Right? So from here we can take NCR upon NCR minus 1 is 5/2, or n minus r plus 1 upon r is equal to 5/2. That gives you 2n minus 2r minus 5r, that is minus 7r, plus 2 is equal to 0 as my first equation. Moving forward, we can write here NCR plus 1 upon NCR is equal to 12/5, or when you expand it, you will be getting n minus r upon r plus 1 is 12/5. Simplify, you get 5n. Next, minus 5r minus 12r, that is minus 17r minus 12 is equal to 0. Two equations, just solve the two equations. What we are looking for? We are looking for the value of n only. We get, on simplification, the value of n as 118. So let's write down at the right place for this question. The correct answer is 118. I'm sure this is clear. Let's consider the next one. Next question says, if the variance of the terms in an increasing AP B1, B2, B3 up to B11 is 90, then the common difference of this AP is, let's try this question, B1, B1 plus D up to B1 plus 10D. Let's consider this is AP. It is given the variance is 90. We know what is variance. Variance is given by summation xi square upon n minus summation xi upon n whole square. Right? Where obviously I is varying as per the requirement, as in this case this is 1 to 11 because total 11 terms are there. So this is equal to, when you write the first one, it is B1, then B1 plus D, then B1 plus 2D and so on. So we can simply write it as B1 plus RD whole square, where R is 0 to 10, divided by 11 minus, when you talk about summation xi, that means sum of these terms. So here we have summation B1 plus RD, again let's say R is equal to 0 to 10 divided by 11 whole square. I'm sure this is clear now. All right. Moving forward, we can write this is equal to 1 by 11 times. Now this one we can simply expand and we can rewrite it as summation R is equal to 0 to 10 B1 square plus 2 B1D R plus D square R square. This is clear? Next, minus. What is there? When you simplify this one, you will get 11 B1. Let's write down. Minus 11 B1 plus, when you apply summation over this from 0 to 10, so basically this is 1 to 10, you can straight away say, so it is 10 into 11 upon 2 D divided by 11 whole square. I'm sure this is clear. Some more calculation part is left and then you will be at the end of this question. So let's go ahead. 1 by 11 times. When you apply this summation, you will be getting 11b1 square plus 2b1d multiplied with summation 0 to 10 or 1 to 10, it is same. So it is 10 into 11 upon 2, right? Plus d square into 10 into 11 into 21 upon 6. So this is for the first term. Moving forward, for the second one, which is to be subtracted, minus, let's see, 11 is cancelled over here. So we have b1 plus 5d whole square. So we can write it b1 square plus 10b1d plus 25d square. I'm sure this part is clear. We can also see that 11 is cancelled here as well. Now b1 square and b1 square is cancelled, just some simplification is required. This value is given to me 90 is equal to 90. So here we have 10d square is 90 or d is 3. As it is given to me, this is increasing AP, so just discarding value minus 3, we get d is equal to 3. The same thing the question was asking for, common difference of AP, so it comes to be 3. Let's move on to the next one, that is the last question of this paper, which is question number 25. Let the position vectors of points A and B be given by this one. A point P divides the line segment AB internally in the ratio lambda is to 1, where lambda is positive. If O is origin, then OB dot OP minus 3 times modulus of OA cross OP whole square is equal to 6, then find lambda. Let's try this question. When we see at this one, let's do one thing. Draw a line like this. Mention here points like A, B, and say here P. Also you can mention here O. Correct? Now do one thing. Join with O to A, P and B like this. Correct? Now coordinates for A, it is say 1, 1, 1. For B, it is 2, 1, 3. So for P, which is dividing it in the ratio lambda is to 1, we can say it is 2 lambda plus 1 upon lambda plus 1, comma, lambda plus 1 upon lambda plus 1, comma, 3 lambda plus 1 upon lambda plus 1. So these are the coordinates for point P. Now what the question is talking about, we have to form simple vectors OB, OA, OP and have to put the values. Therefore, OB dot OP minus 3 times OA cross OP whole square is 6. That means OB vector, so this is given to me, OP vectors given to me, dot product, when you have A1i plus B1j plus C1k, A2i plus B2j plus C2k, what's the result of dot product? A1A2 plus B1B2 plus C1C2. So here you have 2 times 2 lambda plus 1 upon lambda plus 1 plus 1 multiplied with lambda plus 1 upon lambda plus 1. I can keep 1, but I have to take at the end LCM, so let's keep it as it is. 3 times 3 lambda plus 1 upon lambda plus 1. So this is OB dot OP term. So let's write it separately. This is OB dot OP. Just simplify further. Therefore, OB dot OP is equal to, we can see 4 lambda plus 1 lambda plus 9 lambda. So this is 14 lambda, 2 plus 1 plus 3 plus 6 upon lambda plus 1. This is my first term. Moving forward, next is OA cross OP. So this is I, J, K, 1, 1, 1. And we have here 2 lambda plus 1 upon lambda plus 1, lambda plus 1 upon lambda plus 1, 3 lambda plus 1 upon lambda plus 1. Simplifying it, we can see 1 into this term. So obviously 1 upon lambda plus 1 will be common throughout. Now I times, what is there? 3 lambda plus 1 minus of lambda plus 1 giving you 2 lambda minus j cap times, here you have 3 lambda plus 1 minus 2 lambda plus 1, so giving you just lambda, plus k times lambda plus 1 minus of 2 lambda plus 1 giving you minus lambda. So this is the result we are obtaining. We can say this is lambda upon lambda plus 1 multiplied with 2I cap minus j cap minus k cap. Now we need its modulus as well. So let's go for it. Therefore, OB dot OP minus 3 times OA cross OP whole square as given here. So this is equal to 6. This is cross term. Let's go for 6. Substitute it. OB dot OP, please recheck the value. It was equal to 14 lambda plus 6 upon lambda plus 1. It was 14 lambda plus 6 upon lambda plus 1 minus 3 times square of modulus, correct? So this is lambda square upon lambda plus 1 whole square multiplied with, let's see the modulus, this is root 6, its square is 6. So just simplify to get the final answer for lambda as 4 by 5. So I'm sure this part is clear. Now we have to write it in the form of numerical value. So yes, we can write the correct answer for this question is 0.8. So I'm sure this question is also clear. So this is about question number 25 of this paper of 2nd September evening shift. This is all for this paper. All the best. Thank you for watching.